Hello and welcome. My name is David Malone, and with my colleague Steve Emsley, run an organisation called Northeast Electric Cars. Don't worry, we're not about selling anything. Our aim is to simply try to remove some of the doubts and misinformation about the transition to clean, green, safe and smarter transport. At the end of the presentation there will be a screen with links including our website which contains more useful information. And you'll get your chance to ask any questions about electric vehicles. I'll hand you over to Steve now.
We think it's a very big transition looking at travelling in electric vehicles. We're coming in from the perspective of we want to do something about climate change, we want to reduce emissions, and we want people to be able to go electric so that as we get greener and greener in our electricity, the vehicles can take advantage of that. And many people are already using them in that way and plugging them into places where they can get renewable electricity. We'll talk about that more as we go through. Anyway, there are two kinds of so-called electric vehicles. We're very much concentrating on the first one down here, the battery electric vehicles, the BEVs. They're the ones that really have their place, come of their time now. Hybrid electric vehicles are still around a lot. Companies are still pushing them a lot, but they are still in the category of using fossil fuels, and we're trying to get away from that. So we're really promoting battery electric vehicles. They have come such a long way that they've really taken over from hybrids in terms of what they can cope with without using fossil fuels. So there are two main reasons people give for wanting to try or buy an electric vehicle. Both of them have popped up there. You may have other reasons, and you might like to relate to those in any questions that you put forward, because there are many other reasons people might do it. But those are the biggies, if you like. Okay, as I said, in terms of climate change, we're talking greenhouse gas emissions and reducing them. 36 million internal combustion engine cars that I might sometimes refer to as ICE, internal combustion engine, in Britain, probably releasing something in the order of 150 to 200 million tonnes a year of CO2 equivalent. So we're trying to knock that out and in our own small way contribute to that shift. Obviously, you don't have an exhaust pipe on a full electric vehicle, so we're not putting out emissions as we drive. There are some emissions that come from elsewhere in the production of the vehicles and the fuel, but we'll be looking at that. Petrol and diesel vehicles are reckoned to be causing deaths of 40 to 60,000 a year, somewhere around about the coronavirus total at this point in time, when we're getting that every year. Very few cars so far are already fully electric, somewhere in a sort of 1% kind of level total on our roads. So we have a long way to go in this shift. Using renewable electricity obviously cuts down the emissions again. This is a bit more personal experience here. There isn't any road tax to pay on full electric vehicles. Average cost that I got on my last car before an electric one was a Peugeot 206, and we worked it out, we were spending 18 pence a mile on that vehicle. It wasn't a great goer in terms of mileage, but basically that's not far off an average for many vehicles. Bigger vehicles, it would cost you more than that. When you change over to electric, it's easy to get it down to somewhere on normal home tariff rates of around about 4 pence a mile. It's around about 16, 17 pence a kilowatt hour. You get about 4 miles out of a kilowatt hour. Nighttime charge, if you get onto economy 7, you can knock that down to tuppence. We use a bit of solar in our mix off our own roof as well, so that bangs the cost down further. Cheap services. We have something called regenerative braking in full electric vehicles, certainly, that puts energy back into the battery. You can't regenerate petrol or diesel. Once you've burnt it, it's in the atmosphere. With this, you can get about 10% extra mileage from the engine, basically capturing the energy when you're moving down a hill or when you're slowing down or when you're braking. A percentage of that can be put back into the battery. And there is a very simple MOT process. It's almost a joke to sort of say, yeah, they like to change your windscreen wipers, and if a bulb's gone, they'll replace it, but not much else seems to go wrong. Loads of parts not there that would be there in a petrol vehicle. And insurance, yeah, it's worth shopping around and finding out. There are some companies now starting to specialise in electric vehicles. On the discussion about how green are EVs, well, the first thing I would say was I wouldn't be doing this if they weren't a far better proposition for the environment. I just wouldn't touch it. I've done a lot of work around all sorts of other green issues of household energy and food growing and all sorts. I wouldn't look at it if I didn't think battery vehicles really did make a big difference. That's just my personal commitment. On the left-hand side of this bar chart here, you see an average Euro car that is a petrol or diesel average. And it's got 3 sections in it. The blue one at the bottom there being sort of general manufacturing to produce the car, the emissions from that, okay, so that's been estimated. The fuel cycle, i.e. producing petrol or diesel, averaged, and that amount of emissions just to get the petrol to the pump, basically. And then you've got the tailpipe emissions from burning the fuel in the car, which are relatively massive, that big grey column on the left-hand side. The hybrid, beside it, the Toyota Prius is the most common hybrid, a very successful car, and it cuts down your emissions, I think it's fair to say. On the right-hand side, we've got a Nissan Leaf, the 40 kilowatt that first came out in 2018, and it shows across Europe and then one or two other places as well, the emissions averages in those areas. So that's assuming the average energy mix in those countries, which will be part one thing, part another. So if you look at Norway, doesn't have the orange bit in it on the fuel cycle because they're using hydro energy. Up to 99% of their energy in Norway is from hydro. So you can estimate that as an incredibly low level, basically, of emissions. And you can see that France is pretty low because they use nuclear, and that is considered, and it's arguable, but it is considered to be very low emissions. Large amount, I don't know the percentage, but a large amount. The EU average, you can see there, the orange bit in the middle represents, well, there's quite a bit of coal burning still going on. And actually the UK has got a lower level of coal burning. As you can see, that orange bit is a bit slimmer than the EU average. In fact, it's about half of it. And in the United States, they're burning as much coal as they can, and I expect that orange column to sort of disappear out the top of the screen the way Trump's going at the moment. If coal was being brought back, but actually it's collapsing, although Trump is very supportive of it. So you can see there's quite a difference. Now, other things that add to that difference, in the UK, if you're using renewable electricity in your vehicle, then you're going to be cutting out most of those emissions in that orange part there. So if you're buying from a renewables company or you're using public charging facilities that use renewable electricity, and most of them do, then actually it's a bit unfair to call it the UK average, because you're using renewable electricity to charge it. So that orange bit starts to shrink right down. I won't go into the other countries. They have their reasons for their levels of averages. Looking at this one, this is basically how long does it take to pay back the carbon debt. There's a concept of actually constructing the car and getting the thing on the road. You can see that the way this is estimated, in the first couple of years, the orangey brown columns are slightly larger than the grey ones, showing that there's still actually a bit of carbon debt there on the first two columns in the first year. And then you start to reach a position where the grey column gets larger. And this is on the Nissan Leaf, on the one we were looking at, the 40 kilowatt Nissan Leaf, the one that does about 140 miles range. And as you can see, the longer you use it, the more you're saving carbon emissions. Okay, so if you have a car for 12 years, you paid back the carbon debt many years before. So I mean that's the picture basically. The smaller the battery in the car, the more quickly the carbon debt is paid off. So if you've got a 24 kilowatt Leaf, it's paid off more quickly than what it shows on here. And if you have a whopping great Tesla with a 90 or 80 or 90 kilowatt battery in it, it'll take substantially longer. But that's the sort of average on the Nissan Leaf. So battery electric vehicles, you charge them from the mains, whether it comes through a public charger or whether it comes through a charger in your own house, or even if you just plug the thing into the mains, which you can do. And it stores the electricity in the battery, and basically a large amount of that energy is put through to the wheels of the car when you tap the battery. And the hybrid vehicle, basically, it's not a full battery vehicle. The batteries in them are usually relatively tiny, only do about 20 to 30 miles at the very most. A lot of people think hybrid means 50-50. It doesn't. It means if you drive it for any distance, you're switching over onto petrol and you're staying on it. If you're just doing short journeys around town and you've got a plug-in hybrid, which you can plug in and charge, then yes, you can get away with around 20 miles on the battery. And if it's not a plug-in one, then you're using petrol to charge it. Right, what they're like to drive. Well, there's a list of stuff up there that you can read for yourselves, and you've got the regenerative braking, but the actual experience of getting into an electric car, first thing is, oh, right, I don't have to change gears, right? Getting used to an automatic. The biggest challenge for me, it took 10 minutes to get used to that bit. And basically the sort of high torque, as it's called, the instant takeoff of an electric vehicle, it's quite extraordinary that the power goes from the battery to the wheels quite as rapidly and efficiently as you're not used to in a petrol car, believe me. The general experience is one of relaxation, of losing quite a lot of the stress. If other people are behaving like idiots, you can get stressed in any vehicle. But basically the noise and the sort of tension rising of the noise of gear changing and engine roar, it actually loses that. And you get a much more relaxed situation where you can hear if you're playing music, or if you're talking to someone on the phone while you're driving, or if you've got people in the back of your car, which often is a hard of hearing situation in a petrol vehicle. It's dead quiet. It's a really nice experience. So that's I think that's a real plus. If you really are at the other end of the scale and you like the roaring engine noise, then you can buy an app that you can stick on your phone and have a roaring engine noise to go with your electric vehicle. I haven't. And all the usual bells and whistles, and there's camera parking on some of them and all of that sort of stuff. I've got surround cameras on ours, and it's no great tricks, but it's quite handy in limited spaces, or if there are bollards around the place, it's quite good to be able to see the back of the car down low. And I've used the warnings. One of your tyres is under pressure warning. It's always a nice one. Battery life, boy, has this one changed. Electric vehicles basically have been around for 10 years now. The sort of mass market in them started with a big car in the States, the Roadster, and with the Nissan Leaf in Britain, and across many other countries as well. The Nissan Leaf became the market leader. I don't know how many they've sold, but 400,000 upwards. The battery life in these things, when they first came out, you could guarantee it wasn't going to do more than about 80 miles. And the life was, I suppose to some extent, it wasn't even known because they hadn't been around for that long. And the more they've been around, the more people have been finding that there are big improvements. So the first generation of batteries weren't as good. The second generation, quite a bit better. And they're now finding that it's something like a 15-year life. You might get a bit of downgrading in the amount of performance the battery will do, but it's still very usable in an electric vehicle. And we're now finding huge amounts. I mean, it mentions a Leaf taxi there that did 150,000 miles with very little care and little battery degradation down on the south coast. Tesla's clocked up 500,000 miles on its battery pack, and we now have a new Lexia battery vehicle coming out this year, I think, very soon anyway, that's guaranteeing 600,000 mile performance, which is phenomenal. That's basically more than the life of one vehicle in most instances, and possibly 2 or 3 vehicles. So batteries are just taken off exponentially. Really interesting. How far can the car go on a charge? Don't think just in terms of, that's it. This car does 200 miles and that's it. I mean, there's a charging infrastructure out there. You can keep going just like with petrol stations. It's just slightly different. So an average of 4 miles per kilowatt hour. So if a car has a 50 kilowatt battery, one would expect something in the order of 200 miles. It might be a bit less than that, and it does depend on all sorts of things, exactly how far you get. You get a little bit less in the winter. The batteries are colder. They don't perform quite to the same level. In the summer, they sometimes surprise you how much better they do perform. The Nissan Leaf, the 40 kilowatt one, we're looking at something like 160, so 4 times 40. And you can probably work out the sums of the other ones yourselves. The Tesla 60 kilowatt, you might be expecting something in the range of 220 miles for the standard one. And there's one of them, there's a bigger battery that does over 300. And your average mileage, you will know for yourselves probably what your average mileage is. I would say the best thing to think about is not what's the longest journey I ever want to do. If you want to do a 500-mile journey in a battery car, it's going to take you some time, and you're going to have to charge it up a lot or a bit, depending on how big a car you get. What you really need to think about is, what do I do most days? And then what do I do most weeks? And what's going to be a sensible price to pay for a car that does that kind of range? And I can charge it up. If I can charge it up at my home, that's great. If you can't, where's my nearest charger? How long does it take to charge up? What does it cost? It's always cheaper. The range of electric vehicles this year is kind of takeoff year. David's done this enormous thing that looks like a car crash. It's great. With a selection of some of the 200 electric vehicles that we're going to be seeing out by the end of this year, or thereabouts anyway. COVID may have delayed some of them a little bit, but most manufacturers have got an electric vehicle now. So if you've got a favorite company and you want to have a look at their first model or their second, and some will be having a range of 3 or 4 different models for different budgets and different needs, from little tiny distance commuter cars right up to I want to go a long way in this one and do it regularly. Charging. Well, I'm one of those people who charges at home. I got a free charger, basically, government grant, 500 quid, 200 or 250 maybe from Nissan. When I bought a second-hand car from Nissan, they still had that offer on. You could often pressure workplaces. They can get a government grant to fit chargers at work as well. Up to 20 chargers for any single workplace. They would give a £500 grant from the Office of Low Emissions Vehicles, is who pays that out. Many workplaces will give you free charging as well. Some will charge you, but there's another way of getting free juice, basically. Public networks now, we'll come to more about those, but they are there and they're developing rapidly. Okay, so there's 3 examples of different home charging devices. The one I've got is the one in the middle on my garage wall, and I've kind of future-proofed it a bit. I've got one that will charge something bigger than my old and rather small Nissan Leaf battery. It'll do twice the speed that battery will take. So I can move on to the next generation of car and use the same charger, and it will do it twice the speed. Okay, public charging. There's a thing called ZapMap. It shows a lot of, or virtually all of the chargers around the UK, and they are over in Ireland and France and all over as well. There are basically something in the order of 32,000 now nozzles from which you can charge electric cars. Not all of them will be the charger that you want, but in most places there are 2 or 3 different types, and you can look up on ZapMap, which is an app for your smartphone, and many electric cars will show it on a screen in the car as well, or they'll have their own version of it to show where the chargers are, and you can look up the information very easily as to, is it in use, is it working, what company is running it, what do I need to make this work for me. So you can plan those kind of things in advance and know exactly where you're going to stop and try and work it out to leave yourself a little bit of leeway. Motorway service chargers started with Ecotricity, the renewable electricity company, many years ago. They started something called the Electric Highway. Now there are chargers in car parks, hotels, gyms, all those things listed there. And on street sides in many places you can get chargers as small as a little round thing on a lamppost, can do charging as well. Different places have different ones. And this is the growth in public chargers. So if you were trying to run an electric car in 2011, it was possible, but there weren't that many chargers and you were a bit stretched. So you probably did most of your charging at home anyway. And if you were going on a long journey, you just had to be more careful. Whereas when you look at it now, I don't know how many times it is compared to 2011. There's probably 20 times the number of chargers as there were then. And there's a great number more of what they call fast. So the yellow ones are slow chargers, blue is fast chargers, and the ones we use when we're going on longer journeys tend to be the purple. And in the very, very new generation, there's a few hyper-fast ones around. A fast one might do a good part, like 80% of your battery will be filled in 30 to 40 minutes. The hyper-fast ones are just like 10 or 15 minutes and you've got 100 miles on your car. My car wouldn't take them. A brand new car, some of those are coming out this year, will use hyper-fast, and the Teslas use things like that as well. They've got their own kind of section of chargers all over the country. They've got their own network. I can't use my Leaf on those, but they have a network, which is amazing. And the first Tesla Model 3 I ever saw was in Anik, and it had come from Madrid. So that's not a bad little drive in a battery vehicle. So there we go. There's something like the ranges of what you can put into your car using rapid chargers. You use fast chargers in places like car parks. If you're going for a shopping trip or a walk around or looking at an attraction in a place, you might put it on a fast charger. Rapids are sometimes time limited, so you might get 40 minutes or an hour allowed, and then you've got to get off it, so you're not just hogging a parking space. The fast chargers, you can leave things on for a few hours generally. The slow chargers, it can be like an overnight job, or you can just get a few miles if that's all you need. Like, say, for example, charging at a friend's house kind of thing. If you need to plug in at a friend's house, you'll probably only be there long enough to get a few miles on the car, but it might be enough to get you home. Are they expensive to buy? Well, when it first started, I think the answer to that was yeah, they were very expensive to buy, and the battery costs were absolutely enormous. But like everything else, once you start getting a bit of scale on the sales, and a lot more research went in, and a lot more density of battery, as they call it, a lot more power in the battery and a lot more range, the price has come down and down dramatically. Maybe all of it hasn't been passed on to the owner of the car yet. Maybe they are making a bit more money out of it, but they're getting very competitive. Yes, some of them are still more expensive than the petrol versions. When you get into second-hand cars of 2 or 3 years old, you find much more parity of price of electric vehicles with petrol cars. They do a good job of being at a price point that kind of crosses over with the price of petrol cars. It's not true of every single one of them. You need to look at the things that you're interested in getting and find out whether a new one or a second-hand one suits what you're doing. At the bottom there, it said 2-year-old cars are around about the same price point when it comes to petrol cars and battery cars. There's some new examples there. Some of these cars are not been around very long. I haven't even encountered some of them myself yet, and some of them are older. But those are the sort of price range on the models mentioned there, and the used ones underneath, the 7,600 and so, probably done quite a few miles. It's probably a few years old. The Renault Zoe, as you can see, it was a 22 kilowatt battery car originally. It's not on the top list there, but the new one is a 40, I think, if I remember. No, it's a 50. It's a 50 kilowatt Renault Zoe. And you can even get a little Fiat 500 type size vehicle this year with a battery in it, and it does some incredible range. It's unbelievable. It's a very small car. Running costs, this is obviously quite a big factor. A lot of people want to know about this stuff. It's probably best to assume that the insurance is round about the same for a comparable car, and servicing is reckoned to be round about 1/3 because there are so few parts to service, and very few of those are parts that are going to go wrong. They're not rubbing against each other like pistons and tappets and all the rest of the stuff in an engine, car engine. Fuel costs, well, at 4 pence a mile, you ain't going to find that in petrol cars. And you can get that down with special EV tariffs. I think there's about 3 companies so far, electric companies, doing special EV tariff rates. So you can put a bit more onto your electricity bill, but they can bring the cost down. And public charging, it goes at anything from free to about 8, maybe 9 pence a mile charges, depending where you are. The faster the charger, the more you're likely to be paying for. And there are various different systems at the moment, but basically the system's being standardized so you can use a tap-on credit card or debit card to pay for it, because there's all sorts of other fiddly-diddly systems around, and I'm a member of 1 or 2 of them, and they work, and that's fine. And I've got an app on my phone, but really, you're just buying electricity, so really we should be able to slap a card onto it and pay for it. Should be nice and simple. And the government has actually passed legislation saying all new chargers should have that device on them. Safety wise, NCAP is the European safety standards, and a whole load of electric models, it's not all of them, but it's a big range of them, hit 5 out of 5 stars on safety, and there's no reason that they should. And the regenerative braking actually helps, because as soon as you take your foot off the accelerator, you've got some regenerative braking slowing you down, and then you can use your brakes on top of that. So you can stop quite rapidly in them. Yes, you can charge them in the rain. There are very sensitive sensors that are put into the devices, so they're not going to charge your car if there's anything going to short circuit with the water. Battery systems will shut down and isolate if there's any malfunction. Because there's no petrol tank, no fumes, no exhaust pipe with holes in it, no holes in your floor, letting fumes into the car, an explosion in an accident is not going to happen. And of course, there's no carbon monoxide to poison you in your car, and all sorts of other stuff to do with safety.
Thank you, Steve. So it's over to you now, and your questions on any subject related to electric vehicles, cars, and we'll try and answer them for you. Remember, there's no such thing as a stupid question. Okay, over to you.